Before attempting any of this work, hire a licensed electrician for your local area. Attempting any of this could find yourself, we call it doing the wiggle, possibly an electrocution, which means you die. Just don't do it. Anyway, that's my disclaimer. People will be foolhardy, but if you don't know what your electricians are doing, and you also maybe want to think about getting certified, that's the purpose of these things. Doing it yourself, turn the power off, hire a licensed electrician, and gain some experience first, okay? Here we go. Power shut down, safe to work. And we're gonna get this swapped out to a ground fault circuit interrupter and get this garage at least safe from electric shock for anything moist out here, anything else going wrong. Let's get going here. If you're ever wondering if an outlet can be mounted sideways, upside down, what is the standard way, there actually is no format given, although you might want to go with the boxes. They either kind of mount vertically or horizontally. The plug itself actually is slightly safer if the plug is upside down compared to the standard format. The ground prod will be on the upside. Anyway, we'll get tearing apart here and hook it up. Okay, volt reads are good. Take off the faceplate, it's an all metal one. And see this outlet, as it's put together, it's been put in serial. It's not good. You pigtail, you clump the wires together first and then extend little jumpers to these. Not super unsafe, but not the best way at all. You pigtail them, that way you can take it apart. The box is grounded through the conduit, so it's missing its all ground. There's not a ground run through it, so good place for a GFCI. We'll get these on the line load side set up, and we'll have to test for that in a bit, and then we'll get this garage safe. See, the grounding through the conduit into the boxes works in a lot of cases, but can break down if anyone put plastic parts in, anyone has broken the grounds anywhere, there's separations of conduit, corrosion between the connectors, then you lose the good grounding path. So at that point, there is a fix, just get a ground fault circuit interrupter. Anyway, let's get this thing apart. There's plenty of length in here. Conductors need to usually have minimum like 3 to 6 inches depending on the conditions in the box and what's being connected up. So again, being able to work freely is nice. I'm not worried about saving myself from getting electrocuted at any point, and then you can manhandle the equipment. Just don't shut off a single breaker though. If you don't understand household wire electricity at all, you're not a licensed electrician, turn off the whole house power. Here I was able to turn off the entire garage and know that it's completely dead. You can manhandle the equipment and not have to worry about insulated tools or gloves, and you're not really supposed to be working hot in the first place. Okay, the black and the white in each conduit coming up. So got a conduit opening down here, got the 2 conductors. One of them's what we call a feed or the line, and one will be the load, which goes off to the next outlet, if you would. And we're gonna have to test for that right now. And my hunch is it's actually this pair here, but I could be wrong. So make sure the wires are apart from each other. Let's address those a little bit, and we'll turn power back on, and we'll take a look to see what was feeder and what was load side. And the proper strip length is actually going to be on the back of the GFCI. Once you've done it enough, you can basically estimate the length all the time. And at that point, you can trim the insulation or trim the wire back as needed. That's typically about the right length there. And I got in all the pairs lined up. We'll get out some wire nuts here. We're going to take the hot conductor of each. Put one on there. Separate those 2 out. Cap that up. We'll prep the meter a little bit. It's an AC system. I'm going to set this thing to read volts. AC, it's in DC mode right now. Once AC, let me go turn the power back on, and then we'll give this thing a whirl. Ground fault circuit interrupter. Now, if this were going in a wet outdoor location, you got to get one of these that is going to be rated for wet locations. They are different. It'll cost a little more. It's got the extra light indicator, lets you know it's working, test it often. I suggest in most people, especially in some really steamy bathrooms, like every 5 years, even though a lot of them say they'll go 10, other people might cycle them different. Locations where they're not used and it's not very damp at all, even though they might be near a wet bar location of some sort or a sink, let alone outdoors, that changing them out infrequently, every 10 years, not terrible as long as they're tested all the time. Once again, in super wet locations, get a lot of steam going. I recommend changing them out every 5 years. I've changed out a lot in my day. A lot of them go bad, a lot of them get sticky. And one of the worst things that will happen is they'll actually keep working as an electrical outlet, but its safety feature won't work anymore. So you think you might be protected, but it's not working. As I'm peeling the yellow sticker off here, we'll look at the labeling on the back of this really quick if it shows up here in the light of the dim garage. We take a look at it here, saw the grounding and the neutral kind of a little bit better there, and I think the writing will be the right side up now. And hopefully the words align. Line's the hot side will be identified coming out of the bottom of that, and then down here the load will hook up to the bottom. Look at the very bottom there, right where the glare is lining up. They give you the strip length of the wire. We'll line it up a little bit here. You can see me estimating it, not too bad. Okay, let's get this thing hooked up. Power's off, so got no worries there. Yeah, the tabs usually come locked down here. Screw terminals would be a better term to call it. Bring them back up, do it loosely. I don't like using power tools here, electric screwdrivers or anything at all. Hand tools are always best. And hopefully the gap can be seen that's created on that side. I'm over here to do the same thing. I'm gonna loosen the bottom one since we will have a line and a load on these. And you'll see those are gonna be brass colored. And these are chrome, silver, steel looking, whatever. The steels are the neutrals, and the brass colored ones are going to be the hots, the blacks. Whites, hots. We don't have a ground in this old garage here. That's actually one of the reasons why I was using this ground fault circuit interrupter, but you can see the location for it down there. And you don't want to run a ground really unless you're going to upgrade the entire garage. The actual code upgrade is just to use these ground fault circuit interrupters, and they can protect all the outlets in the garage as long as you find the master outlet. That's where we're at today. This is the first one in the line. The rest are down the line, so everything else will be GFCI protected. If you don't know how one works, so there's a test and reset button. That's just testing its safety feature. If the current becomes imbalanced on what is coming back, so it's picking up current greater than what should be coming in, if it detects an imbalance there, or it realizes an imperfect load of some sort, a human being is conducting the current. They can do it in a few cycles, a few milliseconds if you would, and you just taste the slight touch of it and it shuts off. You're an imperfect load, senses it, and it goes. Anyway, let's get this thing hooked up. Once again, the bottom conductors here were the lines. So if you had a ground, you'd hook up the ground first. Establish that just in case of anything accidental, even though we shut off the power. Okay, let's get this GFCI hooked up. Once again, we'll take a look at the back. You'll notice the top says line, and that's what we're looking for here. Once again, the brass are the hots, silvers are the neutrals. Get it all the way in. Always when the insulation meets the back there and there's no copper sticking out the back, you're good. It's not going over the depth there. You can put in either top or bottom's all that important. Some people really meticulous and might be the way circuits are coming or going. Might give a priority to those, but NEC doesn't say much about it. There we go. Flip it around. Slide on in. Never been a huge fan of these connections, these terminals. When you get them all the way down, give them a good half turn rotation where they're super snug. There's a limit though. You can pop the plastic and strip that thing out if you give it the He-Man She-Ra effort and break through it all. Okay, so we take a look, and that was our line side. So the bottom is the load side, and this is where the safety feature will kick in for this outlet and for anything downwind on the bottom. And this is not a splice area, so you're not going to hook multiples despite all the entry ports for it all. So remember that as you go. It's not an outlet for pigtailing right now since the connections are simple enough. So 2 safety features improved to date. One, it would be the fact there's no grounding in here, and once again, you don't necessarily have to upgrade, tear all the walls out and stuff like that. Just switch to ground fault circuit interrupting outlets, and that will solve the safety issue of doing ground. But then the second, the outlet had been serialized. They've been hooked in serial. It's not the correct way of doing it. If the outlet fails, you can lose part of your circuit. Also, a good way of loose neutrals causing all kinds of problems. One of the advantages of having the power off and absolutely knowing it's off is just being able to manhandle the work quickly. Working hot, I don't know, I've seen too many things explode at this point in my life, and did fair share when I was a rookie electrician of melting some things and working out. Watched a few people, watched a coworker get arced out in a box, pretty bad, service panel, and got flash burns to his eyes that lasted a good month. It was frightening to watch. You know how red his eyes were. It was really disturbing. Don't work on things hot. Not worth it. It's not the proper way. Turn it all off. Get done with it. Line side here and the load side. One of the things I want to do is do a tuck. It's known as an S tuck. Just don't shove the outlet in, but actually shape the wires. This one's going to work the other way. So do it, get them into an S shape, and then gently push back. If you find yourself forcing it backwards, you're not going to be in the best shape. And with this lower conduit coming in the side, you got to be really careful there. Do a good look inside and out. Clearances, make sure the wires weren't pinched, especially that side conduit coming in can be really difficult with the GFCI. Mistake that can occur here, it's not easily fixed either without surface mounting something, is if you had more conductors coming in and they need to splice them and manipulate them a little more. With this GFCI and the smaller box here, by time for an extension, we're overstuffing the box, doing too much fill on it. See a lot of homeowners with that particular problem sometimes with add-on work. This one's simple enough. Pair coming in, pair coming out, no ground at all. So the volume is right with the device, and the conductor's coming in barely. Once again, I like going back and forth on these, rocking them in. I don't like using a power tool at all. You got like a 9 volt or 9.6 Makitas or 12 volt electric screwdrivers, whatever. Setting the lowest torque settings, but older boxes and remodel work, things strip out pretty easy. One of the things to be aware of when you're doing this is looking at the clearance for the mounting holes for the faceplate we're going to put on. I can see it's lined up heavily there, and it's bent back a little bit there. I'm going to do a little pry magic here. It's my garage. I'm not that worried about it. Be careful in the house. I'm going to just tweak that out a little further. Not much, just a hair. That metal's too close in the back. The screw goes a little deeper than the depth of the metal, and it will push back on you. And sometimes if you do it too quick, it strips out the hole. And I think we are good on both sides here. A few more turns on that side, maybe. And I'm good. And this is an unbreakable faceplate. And the place used to be a woodworking shop from the previous owner. I'm just using it as storage for music gear and my electric tools. I'm not worried about having to have the super heavy duty steel plate in front. Make sure your screws line up. In this case, I'm going horizontal. Don't really matter, but clients hate crooked screws. We have a GFCI. Let's go turn on the power. We'll see what's going on. And now we're going to hit the reset button. There we go. Green light on. Now we'll hit the test and hit the reset. And the light above's plugged into an outlet now, the chain, and you can see where it's killing that outlet. Nice and easy. Once again, consult an electrician, hire an electrician, doing it yourself, turn the power off. Be careful, be really careful. My garage is now electrically shock protected, and I've improved the basic fire safety. That outlet wasn't used heavily though. It wasn't a serious fire hazard, but in a heavily used outlet, having it serial hooked up, not the brightest idea. There you go. Get nice and easy. We'll start working on other portions of the garage here and show you how to get the upgrades done. Anyway, have a great day.